The acceleration of a particle is given, x is displacement and t is time, so x double prime is the acceleration. And it is also said that initially the particle is at origin, so x is 0 initially, and the velocity is 1 feet per second. That's initially, that means when t is equal to 0. So we need to first find the velocity. So if we integrate the acceleration, we will get the velocity, which is x dot or x prime, then will be 4 over 2 sine 2t plus c. Now it's given that at t is equal to 0, v is equal to 1. So this is v, of course. So v is 1, 2 sine 20 plus c. So we get c is equal to 1. So the velocity, expression of velocity is 2 sine 2t plus 1. Then when we need to find when the particle first comes to rest. So when the particle comes to rest, v is equal to 0. So this equation we equate to 0 and we solve for t to get the time when it first come to rest. So sine 2t is negative half. So negative half, that means it will be ASTC. So since sine is negative, it will be this quadrant. So the angle is somewhere there and also there. But when it says when it first comes to rest, we just look at this angle. We know that sine pi over 6 is half. Since it's negative, so it will be sine the third quadrant, so that will be pi plus pi over 6. So I will rewrite. So basically sine pi over 6 is sine half, but since this is negative half, so it will be in the third quadrant. So the angle, this small angle is pi over 6, but the full angle will be pi plus pi over 6. So that is sine 7 pi over 6. Now this one is 2t, so 2t is 7 pi over 6. So t is 7 pi over 12. This is the 12 second. This is the time when the particle first comes to rest. It again comes to rest somewhere there, and if we have to find that when it again comes to rest, that will be that angle will be 2 pi minus pi over 6, and that will be equal to 2t. So this will be 11 pi over 6. So once more it comes to rest at this time, but this is when it first comes to rest. And then finally we need to find the expression of displacement. So velocity is given 2 sine 2t plus 1. So displacement is, if we integrate this one, it will be negative 2 over 2 cos 2t plus t plus c. Now, so I will just write this thing first and then we'll apply the boundary conditions. So it's said that at t is equal to initially, that is at t is equal to 0, the particle is at origin. So when t is equal to 0, x is 0. This is becoming cos 2 0 plus t is 0 and c. So this is negative 1 there because cos 0 is 1 c. So we get c is equal to 1. So our expression becomes x is equal to t minus cos 2t plus 1. So that's the displacement there.